Hello students, I welcome you all on this YouTube channel. So today let me discuss the H parameter model of a transistor. Right? H parameter model of a transistor. So the word H stands here for the hybrid. Hybrid. H means hybrid. HYBRID hybrid, and hybrid means it's a mixture of various quantities, right, that we have to calculate from this H parameter model that we are going to discuss now. So first of all, see the H parameter, the general matrix of H parameter model is given by VI I naught, that is equal to HI HR, HF HO, and II, and this is V naught. So what is VI? VI is the input voltage. What is I naught? I naught, or you can say IO. IO is the output current. What is II? II is the input current. What is VO? VO is the output voltage, right? So this H parameters, all these H parameters basically relates input voltage and output current with the input current and the output voltage, right? That is the general matrix of H parameter model, right? So H parameter model, it's a mixture of various quantities that we will calculate one by one. So this is the matrix, the general matrix of H parameter model, where VI and II are input voltage and input current respectively, and IO and VO are the output current and the output voltage respectively, right? So these H parameters, these are the H parameters which will relate the input voltage and output current with the input current and output voltage, right? So once I open this matrix, what I will get? I will get VI. VI is nothing but the input voltage, right? So once you open this matrix, you will get VI is equal to HI into II plus HR into VO, right? So VI is equal to HI II plus HR into VO. Just open the matrix and you will get this equation number 1, right? Similarly, you can get IO, that is output current IO, that is equal to HF into II plus HO into VO, right? What is I naught? I naught is HF II plus HO VO, right? That is equation number 2, right? Now our aim is to calculate all these H parameters. That means our aim is to calculate this HI, our aim is to calculate this HR, our aim is to calculate this HF, and our aim is to calculate this HO, right? What are these H parameter? What are the name of these parameter that we will discuss, right? So if you first of all tell me that if I want to calculate HI, right, this parameter HI, if I want to calculate, then what I have to do? First of all, I have to make this output voltage 0, right? Because when I make this output voltage 0, then only the second term will be eliminated and I can get HI is equal to VI by II, right? So HI, here you can write HI is equal to input voltage VI divided by input current II, right? Under the condition when VO is equal to 0. What is the meaning of VO is equal to 0? That means when output is shorted, in that case the ratio of input voltage to the input current, that will give you the H parameter HI. Now can you tell me what is the name, what should be the name of this H parameter which is indicated by HI? Can you tell me? It's very easy. Just see, this is the ratio of voltage to the current, right? Input voltage VI to the input current II, right? So VI is the input voltage and II is the input current. So volt by ampere, volt by ampere, you know, it is a ohmic value, it is basically impedance, right? So what is the name, what should be the name of this h parameter, which is indicated by hi? Suffix I stands for input. And what should be the name? The name should be input impedance, right? Because volt by ampere is nothing but the input, it is nothing but the impedance, right? So hi, what is this hi? What does this hi indicate? It will indicate the input impedance, right? That I will draw in this h parameter model, right? Now similarly, if you want to calculate hf, this parameter hf, if you want to calculate, then what you have to do? You first of all, you have to make this second term equal to 0, right? And for that you will have to make this VO is equal to output voltage VO is equal to 0. That means again you will short this output voltage. Once you short this output voltage, you will get HF, that is the ratio of IO divided by II, right? So this HF is basically IO divided by II, that means output current IO to the input current II. That is the ratio that you can get, right, by shorting this output voltage V0 equal to 0. All right. So can you tell me what is the name of this h parameter, HF? See, this HF is nothing but the ratio of two currents. IO is the output current, II is the input current, right? IO is the output current and II is the input current, right? So output current by input current, it is the ratio of two current, it is nothing but the current gain. It is nothing but the current gain, right? So this HF is nothing but the current gain of the transistor, right? Current gain of the transistor, right? So if you take a common ammeter model, then suffix E you have to write here, HFE. So this HFE is nothing but the current gain, that commonly you can call it as a beta in case of common ammeter configuration of transistor, right? So that is HF, current gain, that is the ratio of output current IO divided by II under the condition when output is shorted, output voltage V0 is equal to 0, right? Similarly, can you calculate HR and HO? Yes, definitely. How to calculate HR? See here, if you want to calculate this HR, then first of all you have to make this first term equal to 0, and that is only possible when II is equal to 0. When II is equal to 0, in that condition you can calculate HR. So when II is equal to 0, what is the meaning? The meaning is that you have to open circuit the input. So when you make input open circuit, that means input current will be 0. In that case you will get HR is equal to VI by VO, right? Because II, that is input current, you are making input open, that means II is equal to 0, that means this first term becomes 0. Finally you will get HR is equal to ratio of VI to VO, right? So HR is equal to input voltage VI to output voltage V0, VO, right? So that means HR is equal to VI by VO. HR is equal to VI by VO under the condition when input is open. That means when II is equal to 0, input current II is equal to 0, right? So see here, this is the ratio of input voltage divided by output voltage, right? And it is not like output voltage divided by input voltage, right? Since it's a ratio of input voltage to the output voltage, that's why you will call it as a reverse voltage gain, right? So that means HR is nothing but the, what should be the name of this H parameter which is indicated by HR? It would definitely be reverse voltage gain, right? Reverse voltage gain, right? Because it is the ratio of VI by VO and not the ratio of VO by VI, right? So HR is reverse voltage gain, right? Reverse voltage gain, right? Similarly, can you calculate HO? For calculation of HO, simply you have to make this first term equal to 0. That means again you have to make II, that is input, open. II, make it II is equal to 0. That means make input 0. That means HO you will get IO by VO. HO you will get IO, output current IO, divided by output voltage VO. So this is under the condition when input is open, that means when II is equal to 0, right? So this is HO. Can you tell me what is the name, what should be the name of this parameter HO? See, this is ampere by volts. Ampere by volts is a unit of admittance. It's a unit of admittance, right? Ampere by volt is nothing but the unit of admittance. So this is basically admittance. Admittance of what? Output. Output admittance, right? So HO, the name of this parameter HO will be output admittance under the condition when input is open. So that is IO by VO, right? Okay. Till now you have understood, right? That's very easy. Now my aim is to draw the H parameter model, right? So I will simply take these two equations, equation number 1 and equation number 2, and using these two equations I will draw the H parameter model of the transistor, right? So see here, just analyze equation number 1. Just analyze equation number 1, that is Vi is equal to HIII plus HRVO. Suffix I indicates input, suffix O indicates output, right? Suffix R indicates reverse, right? Suffix F indicates forward, right? So Vi is equal to HIII plus HRVO. This is the equation number 1. So see here, Vi is nothing but the voltage, right? So voltage will be equal to voltage plus voltage, right? So HIII is nothing but the voltage. HIII is nothing but the voltage drop, right? And HRVO is another voltage, right? So basically you can add voltage to voltage. That means to represent this equation number 1, you will have to make a loop. You will have to make a loop, and in that loop when you apply Kirchhoff's voltage law, you will get this equation number 1 that I am going to draw now. See how? See here. Just analyze equation number 1, right? Vi is equal to HIII plus HRVO. V is voltage. So voltage is equal to voltage plus voltage, right? You can add voltage with the voltage, right? You cannot add voltage with the current, right? That is understood. So that means Vi is equal to HIII. HIII is the voltage drop in this input impedance HI, and HRVO is another voltage. So you have to represent this in H parameter model. So here this, just have a look at it. This Vi is the input voltage and this II is the input current. So now here, since HI is an impedance, so impedance means you will have to draw it like this. That means you will have to draw this in impedance in series, right? So this parameter, this you will call it as a input impedance HI, right? HI. So when this current II will flow in this HI, it will give you voltage drop IIHI. That is the first term of equation number 1. Now again you see HRVO is another voltage, right? So another voltage, how to make it? You will have to draw another voltage here. That means you will have to draw this voltage like this. This is HRVO, right? So this voltage is HRVO. This voltage is HR, right, and voltage. So this is the voltage which is basically depending on voltage, output side voltage V0. So this is basically dependent voltage source whose voltage depends on output voltage V0. So this is HRVO, right? Now once you apply Kirchhoff's voltage law in this loop, you will get equation number 1. See how? Minus to plus Vi. In the direction of current flow there is a voltage drop, that means later sign will be negative, this will be plus. So here you will get plus Vi minus HIII plus 2 minus HRVO is equal to 0. That means you will get equation number 1, right? So this section basically represents the input section of your H parameter model, right? Because when you apply Kirchhoff's voltage law, you will get equation number 1. That means Vi plus Vi minus IIHI plus 2 minus HRVO is equal to 0. Loop completes. That means Vi is equal to HIII plus HRVO. That is equation number 1. So you have now drawn input section. Half of the work is over. Now this is the second equation. IO is equal to HFII plus HOVU. IO is equal to HFII plus HOVU, right? IO is output current. HF is the forward current gain, right? II is the input current. HO is the output admittance. VO is the output voltage. So this is the current equation basically. So unlike the first equation, in the first equation you have seen that first equation is a voltage equation, right? So voltage is equal to voltage plus voltage, that is equation number 1. Now second equation is basically current equation. See here, current output current I0 is equal to HFII. So this HFII is nothing but the current only. HOVO is another current. You can add current with the current only. You cannot add current with the voltage, right? So IO is a current. So this current will be equal to current plus current. So that means HFII is a current. HOVO is another current, right? So that means to represent this equation number 2, you will have to satisfy the Kirchhoff's current law, right? So Kirchhoff's current law, when you apply, you will get the second equation, that is IO is equal to HFII plus HOVO, that I am going to draw here. See here, HO is output admittance. HO is the output admittance, alright. So see here, since it is admittance, so that means I have to draw it in parallel, right? Had it been the impedance, I would have been drawn it in series, but since it is admittance, so I must draw this in parallel, right? So that's why I have drawn this output admittance HO in parallel, right? Now what is RL? RL is a load resistance which is connected at the output terminals, across which you have measured the output voltage V0, VO, right? So now this term HFII is another term, right? HFII is another term, right? So this is again a current. So that means you will have to draw a current source here, right? In order to represent this HFII in H parameter model, you will have to draw a current source like this, and whose direction will be like this. Are you getting my point? Right? Now you apply Kirchhoff's current law. Kirchhoff's current law, when you apply at this node, when you apply Kirchhoff's current law at this particular node, then you will get, see here, I0 is equal to HO into VO, right? HO is output admittance. When output admittance is multiplied by output voltage, it will give you current, right? So I0 is equal to HO VO plus this HFII, right? This current source will be equal to HF, right? and this is HF into II, right? So when you apply Kirchhoff's current law at this particular node, you will get, what you will get? Tell me what you will get here. You will get here I naught output current IO is equal to HO into VO plus this current HF into II, right? So this is basically a dependent current source. This is a dependent current, right? Dependent current source whose current is depending on the current which is flowing in this input impedance HI, right? So that's how when you apply Kirchhoff's current law at this node, you will get IO is equal to HO into VO plus HF into II, right? So this is the H parameter model of this is a this is the H parameter model of a transistor where this terminal is grounded. Are you getting my point? Right? So this is in general model of this is in general H parameter model of a transistor, right? Are you getting my point? Right? So that's how you can draw H parameter model, right? Now for best amplification, you know that we will use common emitter configuration. So simply you have to put suffix E in each and every H parameter, right? Then this will be H parameter model of common emitter transistor, which is ideally suited for best amplification, right? So for common emitter, if you want to draw, then you will have to write HIE, that is input impedance, right, for common emitter. HRE, that is reverse voltage gain in case of common emitter configuration. HFE, II, that will be the current, dependent current source, that will be for common emitter. Similarly HO, you write HOE, right? So this H parameter, all these H parameter you can write for common emitter configuration. Similarly you can draw the common base configuration. Similarly you can draw the common collector configuration. The model would remain the same, only the subscript notations will change. For common emitter you put subscript E, HIE, HRE, HFE, HOE, right? For common base you will put the subscript HIB, HRB, HFB, HOB. Similarly for common collector you will put subscript HIC, HRC, HFC and HOC. Are you getting my point? So that's how you can draw the H parameter model for any transistor configuration, be it common emitter, be it common base, be it common collector, or be it any configuration, you can draw the H parameter model. So this is in general H parameter model of a transistor, and this H parameter model is used to calculate various quantities like input impedance HI, like output impedance HO, like forward current gain HF, like reverse voltage gain HR. So since all these quantity easily can be calculated with the model, with the H parameter model, so that's why H parameter model is best and it is suitable for calculation of all these quantities. That means current gain, voltage gain, input impedance, output admittance, all these quantity you can easily calculate by H parameter model. That's why you use H parameter, right? So H means hybrid, that means it's a mixture of various quantities, that means input impedance, output admittance, current gain, forward current gain and reverse voltage gain, right? So that is the H parameter model. Now I will stop. So hope it is clear to all of you. Thank you very much. Thanks for watching. So if you like my videos, subscribe my channel, right? Gate IS classes. Thank you very much. See you in the next lecture.